Greetings and welcome, ladies and gentlemen. We're taking a look at page 629. We were talking about solving exponential equations in which the majority of these require the use of logarithms. So here I've got 8 to the x squared minus 2 equals 32. And the idea is that, hey, I've got a variable in my exponent. The only way to deal with that is to log both sides, so that way I can end up using the power property of logarithms. And the base of the log that I use doesn't matter. I prefer using either log base 10 or log base e, just so I have to not write some additional symbol down here or something like that for all the logs that I'll be writing. So let's see. So once I've got this log, I can now take the exponent and move it out front, x squared minus 2 times, so there's parentheses around this. Yesterday during class we had some people last minute add those, which is fine. Just don't forget them, my goal is to get the x by itself. In order to do that, I'm going to distribute this log 8, which really, log 8 is just some number, so don't let that fool you. So x squared times log 8 minus 2 log 8, which always looks like 21 og 8 log of 32. And now I could try to get the x by itself. So I'm going to move this, which is just a constant, really, to log 8, add it to both sides. It's log 8. Actually, wow. Here we go. X squared log 8 equals log 32 plus 2 log 8. And actually, I think, is this one of the ones where we could have... Yeah, you could have also divided both sides by log 8 up here, which we had some students do that yesterday. I ended up dividing by log 8. At this point, really doesn't matter when you do it. And I'll get x squared equals this big ugly thing, log 32 plus 2 log 8. Come on, don't give me lag now. All over log 8. Here we go. Log 8. And to get x by itself, what would I do? Root both sides. Plus or minus, don't forget it. So I'll get x is equal to both of those answers. And this one's going to be interesting plugging into a calculator, so I will do the square root of parentheses, log 32, close those parentheses, plus 2 log 8, double close parentheses, so I've got like this entire numerator, and then divide by open parentheses, log 8, double close parentheses. Oh, that was not divide on my calculator, that was multiplicado. So divide, and I get x is equal to 1.9149, and that plus or minus would be in front of it, so I can account for that. However, will this negative answer work? Well, I mean, we see the answer there represented, but more intuitively, I can't take the log of a negative number. But notice that if I plug that negative number in here, it'd be immediately squared, making it positive, and then the rest of it follows through. And actually, even if this whole exponent was negative, raising 8 to a negative exponent would just reciprocate it, and it would just be a fraction, but still positive. So both of those answers are legitimate. So those work just fine. But the idea is to get a variable out of an exponent, log both sides, use your power property, and then get the x by itself using some sort of means. Oh yeah, that's what I wanted to do. I wanted to alternate reality this. Notice this particular problem. I also could have written 8 as 2 to the third. X squared minus 2 equals 32, which is 2 to the fifth. So this is 2 to the 3x squared minus 6 equals 2 to the fifth. So then I would have had 3x squared minus 6 equals 5. and then you could add 5 to both sides. So this, add 6 to both sides. So this only works because both of these are able to be written in terms of the same base, which most real-world problems will not have that be the case. But I just wanted to point out that theoretically, oh wow, is this going to look so easy as this? X squared equals 11 thirds, and then root both sides, plus or minus, and I wonder if that works out as nicely as I think. What is the square root of 11 divided by 3? Same answer. Same answer. So what do you know? So I just want to point out that in this case, because both 8 and 32 could be written in terms of the same power, we could have used our previous techniques in doing it. All right, but logarithms are more powerful than that because we didn't even have to account for that. So, otros preguntas. What do we got? 29. Let's see. 29 is actually really similar in format to 33. I wouldn't mind doing one that has x's on both sides. How far did we get last night? All the way up to 33. Oh, 33 was as far as we get. 27 is at least a different format. And then I might end up doing one of the odd ones, or one of the ones past what we actually had assigned, just because those would be valuable. But yeah, for 29, just follow the same format. You take the log of both sides, move it out front. Don't forget to distribute the log in that case, just kind of like the previous one. So here's one of a different format. So I've got t equals log base 8 of 200. I guess actually in this case, I could just use the change of base formula, and that's the same as log of 200 over log of 8. And then I could just plug that in a calculator and solve. I might have an alternate route for us as well, though. Log 200, close parentheses, divided by log 8. And I get, yeah, in fact, 2.5480 is what I end up with. This also in, well, I guess that wouldn't be helpful, but I also could have written that in exponential form, where I would have had 8 to the t equals 200, but that's not necessarily all that helpful. I mean, I could log both sides, right? Log. And I'm going to end up putting myself in the same situation in a moment. But so I'd have t times log 8 when I pull that t out front was log 200. And then I'd divide both sides by log 8, which in some ways is kind of a little bit of a derivation of the change of base formula for us. So t equals log 200 divided by log 8, once again, so 2.5480. So whether you tried to write it in terms of an exponential form, you'd still have to introduce logarithms in order to get that to work. Or just directly use the change of base formula, which makes things much nicer. Let's see. How about, I like some of these ones with cubed root, square root. It's interesting. Yeah, I'm looking for one with variables in both sides. Lots of options here. I might do 44. 44 seems like a nice one. So this is just, I want to do at least one example, even though it wasn't on last night's homework, that has variables on both sides. A situation where when you take the logs of both sides, you'll end up having to bring your variable logs to one side and your non-variable logs to the other. That's what we'll end up having. So, once again, well, actually, first let me do some simplification here. What's the square root the same as? That's the same as a what as an exponent? This is an invisible 2 for the index of the radicand. same as a 1/2 exponent, right? So this is the same as 4 to the n equals 5 to the 1/2 n minus half of 2 is 1. And now I could log both sides. Log it, log it. Log, log. Log, it's log, it's big, it's heavy, it's wood. It's log, it's better than bad, it's good. So now notice I've got variables on both sides. The way I'm going to have to deal with that is bringing them together and recognizing this whole time that these log 4 and log 5, they're just numbers. Nombres, friends. So half n log 5 minus log 5, right? And so in this case, this isn't a situation where I would just divide both sides by log 4 because it I have to get the n's together first before I can do anything like that. So I'll subtract a half n log 5 from both sides. Nope, I just wrote long. That's funny. Log 5, 1/2 n log 5. So n log 4 minus 1/2.
Judy Langley, please dial extension 201.
Equals, and that's a negative log 5. We had someone not get a question right the other day because they lost their sign of it. So make sure you're careful with that as well. So any guesses now what we could do? How could I get the ends together or by themselves? This is most excellent. Well, it turns out I could factor an n out of both of those, and then I'll have only a single n left in the problem. So n log 4 minus half log 5 equals negative log 5. And what would I do to get n by itself? Ideas? Ideas? Divide by this big ugly thing. Divide by the bugly. Minus 1/2 log 5. Man, I write a lot of logs. Log 4 minus 1/2 log 5. And I'll get n equals. That's a weird looking n. N equals. Let's plug that in. So that would be neg log 5 close parentheses divided by open parentheses. This entire denominator must be in parentheses. Log 4 close its parentheses minus 0.5 or 1/2 times log 5 double close parentheses. And I get negative 2.7674. And now let's determine whether or not this answer will be legitimate for the original problem. Yeah, we're fine with a negative exponent there. We're fine with a negative exponent there. Yeah, I think that works. Let's see, do I actually have an answer for this? Negative 2.767 is what the book says, and yeah, I'll call it the same. So, in this case, this problem just had a little bit of a pizzazz of simplifying a radical into a exponent thing first, which works quite nicely. But the idea is that when you have variables on both sides, you end up having to distribute and stack those logs together. So the variable logs on one side, the non-variable logs on the other side is the objective. So, all right, Internet friends, thanks for watching. Bye.